Dalton's law of partial pressures makes perfect sense in conjunction with Avogadro's law, which states that the volume of a gas is directly proportional to the number of moles. Recall that if you add moles of gas to a flexible container, that the new mixture of gases will take up more space. Let's consider a scenario where this container is rigid. We can describe each individual container using the ideal gas law. We'll make the blue dots be situation number 1. So it would have a pressure, volume, a number of moles of gas, with the gas constant at a particular temperature. Let's assume that the blue and red gases are in identical rigid containers at the same temperature. Then the red gas would have a pressure, the same volume, possibly a different number of moles, same gas constant, same temperature. We can rearrange the equations to isolate any of the variables we're interested in. Today, we're interested in moles and pressure. If we isolate the moles for our first scenario, we would end up with an expression that is the pressure times the volume divided by the gas constant and the temperature. Or if we were interested in the pressure, we could say that the pressure is equal to the moles times the gas constant times temperature divided by the volume. And the same goes for the red container. If you add the blue and red gases together into an identical container, this would increase the number of moles to moles of thing 1 plus the moles of thing 2. If we take the expression for each of those mole amounts that we derive from the ideal gas equation and add those together just like we physically added the moles, we can factor out the V, the R, and the T from the right-hand side of the expression. Now we can see that the added pressures, which we could call the total pressure, is directly proportional to the total amount of moles. Another way of saying that is that this new number of moles, the total moles, is equal to the total pressure times volume divided by the gas constant times temperature. Or just like saying that PV still equals nRT. At this point, all we have left to do is define Dalton's law of partial pressures. Straight out of an awesome Zumdahl textbook, for a mixture of gases in a container, the total pressure exerted is the sum of the pressures that each gas would exert if it were alone. Make sure that you write down this equation because it'll come in handy when you're doing problems.